Welcome to solverfy.
Okay, in this problem, we're asked to look at transition levels in hydrogen. We're asked to find the change in energy between levels 2 and 1, and the difference between levels 10 and 9. We were asked to show that as n gets very, very large, the difference between energy levels approaches this known value of 27.2 eV divided by n cubed. So this dependence will reduce down to this expression in the limit of big N. We're also asked to take a look at the radius of the Bohr atom, Rn plus 1 minus Rn, and see how the difference in those radii changes as n gets very large. So the equations we'll need, obviously, are the equations for the Bohr model of an atom, particularly a hydrogen atom. We know that the energy level, the nth energy level, is a simple expression, negative 13.6 eV divided by n squared. Similarly, the radius of particular energy level that an electron is orbiting can be expressed as the Bohr radius A naught, which is some constant, which we don't actually need to know for this problem. This constant times n squared. So these are the equations we'll need. So let's jump into it. So to start, we're asked to find the difference between 2 and 1 and 10 and 9, these energy levels. So quickly, using the expression for the energy level of an arbitrary n, we see that we have negative 13.6 eV, 1 over 2 squared, minus 1 over 1 squared, which simplifies to simply 13.6 eV times 3/4. Similarly, with the difference between the 10th energy level and the 9th energy level, we have negative 13.6 eV, 1 over 10 squared, so 1 over 100, minus 1 over 9 squared. Let's actually explicitly show that 10 squared, which will give us 13.6 eV times the fraction 91 over 8,100. Okay, we can plug that into our calculator and get numerical results. But that's not really what's that important about this part of the problem. What's really important is for arbitrary n, can we reduce it down to the simplified expression? So in this case, we have negative 13.6 eV over 1 over n plus 1 squared minus 1 over n squared. So we can do a little bit of algebra to combine these two fractions into one fraction. You're left with negative 13.6 eV, n squared minus n plus 1 squared, all over n squared n plus 1 squared. So at this time, this expression is still exact. We haven't done any approximation or limiting cases yet. So if we consider very large n, for large n, we can say that n plus 1 is approximately n, because if n is some very, very large number, then 1 compared to it should be very little. So we can make this approximation. Thus, delta En, which is simply n plus 1 minus n, just simplifying it a bit. We're left with n squared it's actually worth expanding this first, actually. Let's expand this expression first and then do the approximation. N squared minus 2n minus 1. I'm simply expanding the quadratic. if we do the approximation too soon, we'll get a trivial result. We don't want that. So at this point, we can do the approximation. We can now approximate 2n minus 1 as simply 2n for a very large n, and we can say that n plus 1 is also n. And this is where the approximation comes in. And then we can pull out a negative 2. We have 27. Actually, let's give ourselves some more space. At this point, we have negative 13.6 EV, negative 2n over n squared times n. Pull the negative 2 out. Let's take a look at our last page, make sure this is right. Oh, that's right. N squared. This is where we get the 27.2 EV. We are left with n over n to the 4, which gives us the result. 27.2 EV over n cubed. That's it. So the important part not to miss is to apply the approximation at this stage, at this very stage. If we apply it too soon, then we will not get the expected result. Okay, so now let's look at the very last part where we compare radii of this Bohr model for an arbitrary n plus 1 and n level. So applying the formula, we have n plus 1 squared, a naught, the Bohr radius, minus n squared a naught. Bit of algebra, and expanding the quadratic, we have n squared plus 2n plus 1 minus n squared, which gives us expression a naught 2n plus 1. So we see that the difference in these radii actually increases with n. So between any two adjacent levels, the difference in radius is increasing with n. So that doesn't actually approach any limit. That's limit. That is diverging with n. So that's it. Thank you very much.